Good evening, everyone. Welcome to NPTEL tutorial session for the course Classics in Total Synthesis taken by Professor Krishna P. Kaliappan from the Department of Chemistry, IIT Bombay. And I am Sri Lakshmi as a PhD scholar in the Department of Chemistry in IIT Bombay. So, this is our 11th tutorial session. So far, we have seen discussion about several lectures as well as assignments and mechanisms of the reactions which have been discussed in the lecture, and we have solved several problems also. So last week we have done up to here. We have completed this solving of week at 8 assignment. So today we will be starting with the lecture 45. Before that, we will wait for a couple of minutes and see whether anyone else is joining, or else we can start the session. So today we will start with the discussion on the week 10 lecture. So the first lecture of week 10 was about eastron. So in that lecture we have seen different approaches towards the total synthesis of eastron utilizing double Heck reaction, 2 plus 2 plus 2 cycloaddition, multi-pot organocatalytic synthesis, etc. So estrone is a female sex hormone along with estradiol and estriol. Estronic is a weak estrogen excreted in the form of estrone sulfate in urine. It is having four contiguous chiral centers, an angular methyl group, trans anti-trans junction, and trans hydrindane system. So, in 1963, Trogov's group reported the synthesis of estrone in six steps, starting from 6-ethoxy 1 tetrolone, which is prepared from anisole, and the key reactions involved acid catalyzed cyclization, stereoselective reduction, Clemmensen reduction, and Friedel-Crafts acylation. Then it also included the stereoselective reduction using CBS catalyst, which is Corey's asymmetric synthesis. Then in Tietze synthesis, which came out in 1996, they used a double Heck reaction, and the starting material used was hajosparish ketone. Then in Volhard synthesis of estrone, which came out in 1980, they used a diene as the starting material, and the key reaction involved was 2 plus 2 plus 2 cycloaddition reaction. Then in the next lecture, the lecture 46, 47, 48, and 49 was about Taxol. So in that we have seen application of Shapiro reaction and Pinnacle coupling reaction in the convergent total synthesis of Taxol by Niccolo in lecture 46. So coming to the structure of the Taxol, as we can see, it is having four rings, two six-membered rings. This two six-membered rings, one eight-membered ring, and one five-membered ring. So this is about the core structure of the taxol. It was isolated from the bark of Pacific yew tree in 1962, and the structure was elucidated in 1971 by Wall and Warney through X-ray. It has attracted attention of many synthetic chemists over the last 2 decades, and it has been successfully used for the ovarian and breast cancer treatment. Over 200 groups started this journey towards the total synthesis of Taxol. So far, only 10 groups have reached the shore. A single 100-year-old tree will result in 300 mg of Taxol. This is just sufficient for one single dose for a cancer patient. Fortunately, in early 90s, it was found that 10-deacetyl 3, which is called 10-DAB, a precursor of Taxol, lacking the C10 acetoxy group and C13 side chain in the needles and twigs of the Taxus baccata, the European yew tree. So some analogs of Taxol are Taxotere, docetaxel reported by Pierre Potier in CNRS at Gibbs sur It was developed by Ron Pauline Rora, twice as active as, and it is twice as active as Taxol. Nicolo's synthesis of Taxol came in 1994 using music acid as a starting material. And the synthetic challenges involves highly congested C ring with many chiral centers, 8-membered B ring, then the 686 carbocyclic system, and the key reactions used by Nicolo's group involves Diels-Alder reaction, McMurray coupling, and they use the starting material ethyl acetoacetate for the completion of the total synthesis of Taxol. Then in the next lecture, we have seen the application of epoxy alcohol fragmentation, Chan rearrangement, and Diekman condensation in the total synthesis of Taxol by Holton. The first total synthesis of Taxol came in 1994, and this Holton group in used epoxy alcohol fragmentation for the synthesis of bicyclo 531 skeleton of the Taxol. Other key steps involve Chan rearrangement and Diekman cyclization. Alpha acetoacetate rearranges under LDA conditions to give 2-hydroxy 3-keto esters. So this they used as their key reaction in the total synthesis. And they started with commercially available natural product Pacino. And they have also used Burger's reagent here, and they completed this total synthesis from patcholine oxide in 46 linear steps. Then in the Danishevsky's total synthesis of Taxol, which was the discussion in lecture 48, we have seen the application of Corey-Chekhovsky reaction and Heck reaction in the total synthesis of Taxol by Danishevsky. This total synthesis was reported in 1996, and this total synthesis of Bakatin 3 has been also achieved by Danishevsky et al. In 1996. The most rewarding aspect of the synthesis was the ability to start with wheel and measure keto. Then, in the last lecture of week 10, which was about enantioselective total synthesis of Taxol by vendors group starting from Verbinon, we have seen an efficient stereo controlled synthesis of a highly versatile taxane precursor which provides concise access to Taxol. This strategy provides Taxol in the enantiomeric form in 37 steps from Verbinon, the air oxidation product of pinene. The key reaction of this synthesis involves fragmentation of an epoxy alcohol and photochemical 1,3 alkyl shift. And they have also used Crabtree's catalyst in their total synthesis, and they completed in the total synthesis in 37 steps, which was the shortest total synthesis of Taxol at that time. So that was about the week 10 lecture contents, which was about mainly Eastron and Taxol only. So before going to the assignment discussion, week 9 assignment discussion, you can quickly go through the lecture contents once again. If you have any doubts, please let me know. Otherwise, we will proceed to the lecture assignment discussion. Now moving to the week 9 assignment. The first question is identify the major product in the following transformation. So this particular compound upon treatment with NaOMe in the first step and then BH3 SME to BH3 DMS in the second step, which will be the major product here. So here what is happening is that in the first step, that is it is starting from here, this nitrogen lone pairs will attack at this carbonyl carbon center and this will open up to form this lactam ring. Then in the by this BH3 DMS, this double bond O will get reduced and it will get eliminated. That is, amide will be reduced to this amine to get this product. So the correct answer would be option C. So in the first step, lactone ring opening and this lactam formation will take place, and then amine reduction, amide reduction to amine will take place. Now, the next question is, what is the major product formed in the following transformation? So, here this compound is treated with this Na entry in DMF and heated from 70 to 100 degrees Celsius, which will be the major product here. So here what is happening first, in the presence of this, in the by treating with the sodium acide, this OTS will be substituted with this acide group to form this intermediate. Then with this double bond and this N3, a 1,3 dipolar cycloaddition can happen to form this intermediate. Then an N2 elimination will be resulting in this product. So the correct answer is option A. Moving to the next question, identify the major product in the following transformation. So, this pyridine derivative is treated firstly with benzyl bromide and the second step with NaBH4, which will be the major product formed here. So here the correct answer is this nitrogen will get protected. That is, this imine will get protected with this bromide. So this will be this, not bromide, benzyl group. So this nitrogen will attack over this benzyl group, and then NaBH4 reduction of this imine will give this corresponding product. So the correct answer is option B. Now the next question, what is the major product in the reaction? So this particular compound upon treatment with this MCPBA1 equivalent, which will be the major product here? So here what is happening, this particular double bond is getting converted into the epoxide by NCPBA. So it is helping in the epoxidation of this double bond. So the correct answer is option A. Now the next question, identify the major product in the following transformation. This compound upon treatment with KOH, CrO3, which will be the major product. So here what is happening? Firstly, in the using this potassium hydroxide, this ester hydrolysis will take place to form this compound. So this OAC will become OH. Then in the presence of this chromium trioxide in pyridine, this double bond will migrate to here and this OH will get oxidized to double bond this progesterone. So the correct answer here would be option B. So, firstly, this ester group is hydrolyzed. So, this OAC will become this OH, and then this double bond is migrating to this position, and then this OH is getting oxidized by chromium trioxide to give this corresponding alpha beta unsaturated ketone. Moving to the next question, identify the major product in the following sequence of reaction. So here this diazo compound is first treated with this allylic alcohol derivative and rhodium tetraacetate in toluene under heating condition, and in the second step with BF3 etherate benzene, which will be the major product here. So here what is happening? Firstly, this N2 will be replaced with this allylic alcohol derivative to form this particular intermediate, and then dipolar cycloaddition kind of reaction will take place. So this will attack over here, this double bond will shift over this position, and this will move to here to stabilize this positive charge on this nitrogen to form this compound. So here the correct answer is option D. Now the next question, what is a major product in the following transformation? So this particular indole derivative upon treatment with this acetaldehyde and H2SO4, which will be the major product here. So here the correct answer is this one. So firstly, this acetaldehyde will form imine with this NH2, and then the cyclization will happen. So this is an example for Pickett-Spengler cyclization, and the correct answer is option A. The detailed mechanism of this we have already discussed earlier, so I am not going into that. Now the next question is, match the terpene molecules in the column A with the number of carbon atoms in their skeleton in column B. So you have to identify how many carbon atoms are present in monoterpenes, sesquiterpenes, diterpenes and steroids. So here monoterpenes are having 10 carbon atoms. An example is geraniol. Sesquiterpenes are having 15 carbon atoms. Example is farnesol. Diterpenes are having 20 carbon atoms. Example is geranyl, geraniol. And steroids are having 30 carbon atoms like in squalene. So the correct answer is option B. Monoterpenes C10, sesquiterpenes C15, diterpenes C20 and steroids C30. Now the next question, identify the major product of the following reaction. This compound upon treatment with this particular carbonate and in the presence of this dichloromethane in trifluoroacetic acid condition, which will be the major product. So here the correct answer is option C. And what is happening? This particular compound will attack at this center, and this triple bond will attack over this carbon center. This will attack over here. This will attack over here. This will attack over here. And by TF8, this will get protonated and will leave us water molecule to give this compounds option C. So the correct answer is option C here. The last question of week 9 assignment: identify the major product in the below reaction. So here this particular compound upon treatment with this palladium acetate and PPH3, which will be the major product here. So here what is happening in the presence of this palladium acetate and PPH3? This whole group is getting hydrolyzed, and we are this is getting changed to this position, and this is getting eliminated, and we are getting this option A as the correct answer. So that's all about week 9 assignment. Now maybe we can move into week 10 assignment, and one or two questions we can discuss. First question is identify the major product in the following transformation. So this particular compound upon treatment with this acetic anhydride in DMAP, and in the second step with TPAP and NMO, which will be the major product here. So here what will happen while treating with this acetic anhydride and DMAP, out of the two hydroxyl groups present here, only one of the hydroxyl group will get acetylated, and which we can control by temperature and equivalence. So one of those got protected and the other one will get oxidized under TPAP NMO condition to get this ketone. So the correct answer is option C. Moving to the second question, what are the major products P and Q formed in the following sequence of transformation? So, in the first step, upon treatment with this trimethyl sulfonilamide in THF in the presence of KHMDS, we are getting a product P. Then, in the presence of this aluminum triisopropoxide toluene and reflex, we are getting a product Q. So you have to identify what is this reaction and which is this P and Q out of this options given here. So here what is happening in the presence of this trimethyl sulfonilamide and KHMDS, this ketone will get converted into this epoxide, and so the option P will be this one. Then in the presence of aluminum tetraisopropoxide, this will open and we will be getting this allylic alcohol. So the correct answer is option A. Moving to the third question, identify the major product in the following transformation. So this particular compound upon treatment with this MCPBA in DCM, which will be the major product formed here. So as we can see from the four options, anyway, epoxidation will be the reaction. So you have to identify which will be the regioisomer and which will be the corresponding stereoisomer. So here the correct answer is this one, option B. So epoxidation will take place to this double bond and the stereochemistry will be controlled by this whole substituent. So it will be coming from above and we will be getting this corresponding product as a major product. So the correct answer is option A. Now the next question, which is the major product formed in the reaction given below? So this compound upon treatment with the samarium iodide and acetic anhydride in THF, which will be the major product form? Four options are given here, so which could be the major product? So here this samarium iodide act as a one electron donor. So it will form a radical at the center of this position, and then this epoxide bond will cleave and that will form this enol type of system, and here OH, then elimination will take place and then ketoenol tautomerism to form this alpha beta unsaturated ketone. So here one radical will form, then this will break and this two radical will combine to form the corresponding enol, and here will be OH. So that enol will be existing in keto form. Then elimination would give this alkene here. So the correct answer is option D. So with this we will stop today's session. So if you have any doubts on today's topics or today's questions or any content, please do let me know. Thank you for joining and thank you for listening. So we will be having one more tutorial session as well as one more summary session. With that we will bind up this tutorial sessions for the course classics in total synthesis. So thank you for joining. Thank you. See you in the next tutorial session in the next Saturday.